evening, everyone. Call our Committee of the Whole meeting to order for Monday, November the 25th. Approval of the agenda, that the November 25th, 2019 Committee of the Whole meeting agenda be adopted as presented. Moved. Second. All those in favor? Opposed? Carried. Adoption of the minutes. That the minutes of the Committee of the Whole meeting held November the 12th, 2019 be adopted as amended. Moved. Second. All those in favor? Opposed? Carried. Delegation. Mr. Fortolowski, would you introduce our guest, please?
Thank you, Your Worship, Councillors. We have representing Tree Consulting, Mr. David Underwood. You've met him before on several other issues, particularly water, though. And as promised to Council, this is another step towards the amalgamation decision of the how to bring the 753 into our system. As promised, David will present to you the report, the presentation, and summarize the findings for the scope of work that should be done and the cost of that work. And he'll also entertain, obviously, questions and comments while he's here. I would hope that all of you would maximize this time and feel free to ask as many questions as you like in comments. I'm sure potentially the mayor will allow the committee to hold the goal a bit long to make sure you as councillors get the information you need, and then next week we'll follow that on with the council discussion as far as the strategy moving forward. How exactly will this happen? So maybe I'll pass it on to my colleague Kevin Dickin, if he has any words to say before we have Mr. Underwood go forward.
I think, Mr. Mayor, Council, I'd just like to add that we have done some field work on the 753 system with the permission of the province to try and determine some of the unknowns that are happening with the system. Most importantly, why the reservoir will not fill based on hydraulic elevation. It should be filling from our reservoir, but it's not. Unfortunately, we still have not determined what that issue is, and so you will see in the costing summary that Mr. Underwood has put in some contingency in there, and that is because there are some unknowns. So having said that, Dave, take it away.
Thank you very much. Welcome back. The floor is yours.
Thank you, Mr. Mayor, members of council. Yeah, I think I was here in March last, and yeah, nice to see everybody again. This time I'm here to talk about 753, and specifically since July, when I understand that council resolved to kind of take some next steps here with respect to 753, I wanted to do a little bit more of a detailed assessment to confirm some of the shortcomings of the existing system and to identify the scope of infrastructure necessary to kind of bring that system back in line with the district of hope system. The other thing is obviously we wanted to look at the cost estimates, and we wanted to improve the quality of those cost estimates. We touched on it previously in the Water Master Plan, and we wanted to sort of take an update to that such that council can make decisions moving forward with respect to the system and potentially even some opportunities for grant funding or other opportunities for funding. Just to refresh everybody's knowledge of the district system, the purple system is the 138 zone, meaning the reservoir is at 138 meters in elevation. 753 zone is shown there in red. There is obviously some interconnection of the two zones since 2015, but essentially prior to connection, those were separate systems, red to purple. The blue system is a lower zone, 87. The reservoir says 87 meters. That services all downtown. The Silver Creek zone is obviously a completely separate standalone system, as is the Scottsville Lake. So as we all know, in 2015, due to a source failure there of the 753 system, there was a connection to the District of Hope's water system. It's currently a private system. but stewardship fell to the province in 2017. Since that time, the district has been assessing the implications of connecting the system to the municipal system. And in July, I believe in July 2019, there was an undertaking of council to look at taking over the system moving forward. So I touched on this a little bit when I presented the water master plan. In terms of the network modeling, once the 753 system is connected to the District of Hope system, there is an impact to the district's ability to suppress fires in the 138 zone. And the reason why is because with the Thacker Mountain Reservoir, which is in the 753 area, with that isolated off the system, due to the fact that hypothetically it should overflow. 138 meters is higher than the Thacker Mountain Reservoir, which is 130 meters. Should overflow, historically did overflow. Something's changed recently, as Kevin alluded to. We're still looking at that. We'll touch on that a little bit later. But with the Thacker Mountain Reservoir isolated, that means that there's a high point there on Thacker Mountain, which has very low pressures. And what that means is that when there's a fire elsewhere in the 138 system, those low pressures, marginal pressures at the top of Thacker Mountain are actually coming down, and so you don't want to draw your system into a low pressure or an even worse, a negative pressure situation. So the fact that the systems are tied together with the Thacker Mountain Reservoir isolated is a limitation of creates a limitation of your guys' fire suppression system. And I'll show you that in a minute. Of course, there's also, on the previous slide where we showed the purple and the red zones, there are some areas where there's lines that kind of butt up to each other side by side throughout the 753 area, and you can picture that there be some interconnection, some better interconnection of those two systems, so as to create looping, redundancy, and other resiliency in the system. So this figure is right from the Water Master Plan. What this illustrates in terms of colored nodes is a disconnection of the 753 system, meaning prior to interconnection, prior to 2015. The gray nodes of the 753 system completely isolated from the model. You can see some yellow nodes, and you can see a few red nodes towards Cockaway Lake, but they're very marginally in the red zone. They're actually quite close to providing reasonable fire suppression potential throughout the network. So that's the kind of the before, and then if we go to the next slide, you can kind of see the results and the impacts of connecting the 753 system to the district system. And so that's it's a pretty widespread impact, as I mentioned, and it's all due to the hydraulic elevation of Thacker Mountain and the potential of drawing those high elevation properties into a low pressure or at worst negative pressure situation. So in terms of a review of the infrastructure, the source is one of the key aspects of what we're going to talk about here today. There's simply one well that services the entire 138 system. That's well 10. It's on 7th Ave, near well 3. I think it's clear, it's inevitable that at some point, mechanical failures happen. So at this moment, with a single source supplying the 138 and 753 system, that's a very critical piece of infrastructure for the source of both the 138 and 753 systems. The original Skylark well and former District Well 7 are beyond repair at this point in time, and regulations, the groundwater protection regulation, require those wells to be closed or decommissioned by a qualified professional, such that the aquifer can be protected. So there was also formerly well 9 District Well 9, and there's also a test well that the 753 system had undertaken. They are 200 millimeter, 8-inch in diameter, and that's a limitation. That diameter provides a limit, results in a limitation of the yield that can be delivered from that particular infrastructure. It's possible that the yield from each of those wells may be sufficient to sustain off-peak demand of those two, I'm going to call two systems, 138 and 753, but certainly not maximum day demand. The Riverview well would require land acquisition, and now that there's a Groundwater Sustainability Act in place, it would require licensing, which could take years. Based on the information that we've been able to review, it does not appear cost effective at this time to pursue either of those options. And we recommend that each of those wells should be decommissioned.
Are you saying well 7 and well 9 decommissioned?
That's right, well 7, well 9, Skylark and Riverview. There's 4 in total. 2 district wells, 2 753 wells. So in terms of options, for source water redundancy, well 3, which is in the 87 zone, presently services the 87 zone. That well could theoretically, due to its location, could theoretically be connected to the 138 zone. And then based on the way that the system's set up, it could be we could cascade the water back to the 87 zone if it's needed in that lower zone. So pump water up higher, move it back lower if need be. That's an option. Alternatively, a booster station could be installed near 7th Ave, sort of between well 3, well 10, somewhere around there. And that could move water as it's needed from the 87 zone up to the 138 zone. So you're only pumping as and when, as opposed to moving all water up to the 138 and then cascading down. Of course, downfall with that is, there's some more reliance placed on the 87 zone in terms of you're asking those wells 1, 2, and 3 to do more work potentially. And if you recall some of the recommendations from the Water Master Plan, we looked at the idea of looking at well 11, which is in Silver Creek, and interconnecting that to the 87 zone, given the size and capacity and the yield that's available from well 11 in comparison to the needs of Silver Creek. There is excess capacity available. It would make good sense to interconnect well 11 to the 87 zone, and that would eventually allow facilitate some replacement of some of your older wells, being wells 1 and 2 are quite old. And so this would be a sort of a medium-term plan so as to provide water to that 87 zone, which again could be boosted up to the 138 zone as needed in the event of mechanical or other failure of existing well 10. Moving on from source to storage. As I mentioned, the high elevation at Thacker Mountain represents a hydraulic constraint in the system as it exists, interconnected. So it's really important that a reservoir be established at the top of Thacker Mountain at the elevation of 130 meters. The actual physical condition of that reservoir was largely unknown until this study. We had a structural engineer conduct a review and assessment. There are cracks, both shrinkage cracks as well as some evidence of settlement cracks. There's root intrusion in that reservoir, and there's a lack of frost protection. So in general, there are improvements that are needed. The most significant improvement consists of relining that reservoir with a waterproof membrane. The structure itself is sound, just needs to be watertight. The other miscellaneous improvements include fencing, hatches, ladders, that kind of thing. Miscellaneous sort of improvements there. And as I touched on earlier, and as Kevin has mentioned earlier as well, the reservoir is presently not filling as expected. So in 2015, it's our understanding that it used to overflow, and that makes sense. Hydraulically, it should overflow. We've modeled it should overflow at about 11 liters a second, which is a good flow rate and definitely sufficient to sustain max day demand of that localized zone. So now that it doesn't fill, we need to figure out why. We've conducted some investigations. What we've learned so far is there's been one reading of a pressure from a pressure gauge that didn't make sense. It was lower than we expected. We're trying to replicate that finding, haven't been able to. The other 2 times it's been tested, it's reading exactly as we expect. So either it was an actual error, a human error in recording the result, or it happens when there's demand in the system and we need to somehow replicate that demand to induce a pressure drop or hydraulic loss across something, whether it be a partially closed valve. Lots of times that's something that can happen, is a reservoir or a valve in the distribution system can be partially closed and then it acts as a blockage or a restriction to the water. And when there's no demand, no water running by that partially closed valve, you don't notice any issues. As soon as you induce demand, you start to notice a pressure drop across that blockage. So right now we have a few ideas. We've tried a number of things, working with your work staff. And one thing we have noticed so far is that instead of a loop system, what appears to be a loop system, there is definitely some sort of closed valve near Thacker Mountain Road, Union Bar Road, somewhere down at the bottom there. So that's good to know. Eventually, when the improvements are all completed, it's proposed to actually find that valve and keep it closed. It's meant to be closed, but at this moment, there's no reason for it to be closed. So it's adding to the hydraulic restrictions in the area. So there's some work to be done there, but at the end of the day, the recommendations are to create a new zone called the 130 meter zone, which will be Thacker Mountain Reservoir, and it will only feed that Thacker Mountain Road area. And by isolating into a new zone, it hydraulically disconnects it from the rest of 138, and you can bring those fire suppression numbers right back to where they were before. So in order to do that, there needs to be a few other pieces of infrastructure constructed, specifically what's called an altitude valve, which would be in a control chamber. It would close automatically when the reservoir was full and prevent it from overflowing. So it lets it reach 130 meters, but not anything higher than 130 meters. Closes automatically, draws down with demand, is replenished by the 138, closes at 130 meters, and so on. So there'd be a little bit of infrastructure necessary, but ultimately that's the vision, is to create a new zone there. So one thing that we did learn was like I mentioned, there's a closed valve. So that basically, this slide says that the original thinking was that there was water feeding the reservoir from Lower Thacker Mountain Road. Instead, we've learned that there is in fact a dedicated supply or another supply line heading directly from Union Bar Road essentially up to the reservoir, which is good news. And that was previously, the construction of that very main was something that we had included in the water master plan, but is now determined to be in place and so is no longer needed. But as mentioned, there are still some unknowns in that area that we need to determine the status of prior to connecting the system. We do know that there is an air relief valve on Lower Thacker Mountain Road that has been paved over. We're not sure the operational status. We don't believe that's the isolation issue. That we believe is a different issue, but little things like that need to be dealt with along the way, but all in all, as mentioned, the biggest question mark that exists is with respect to why the reservoir will not fill. So if we want to look at overall improvements, as mentioned, I think the first and foremost, there needs to be a second source to this area of town. Not only the District's 138 zone, but also the 753 zone. The 753 zone additional demand as added by the 753 system sort of just adds to the existing constraint with respect to this source. There's various tie-ins within the residential areas that can be made to increase resiliency and redundancy. We believe that sample ports at dead ends should be installed, and 3 new hydrants are necessary to fill in a few gaps. As mentioned, we want to make Upper Thacker Mountain Road its own separate pressure zone, the 130 zone, and various reservoir upgrades are necessary in support of creating that new zone. So I apologize for this, but we've kind of touched on the improvements. The top, this slide's hard to read, but the top blue box is essentially the existing Thacker Mountain Reservoir. And basically what that note says is reservoir liner, ladders, hatches, fencing, etc. The blue box to the left at the end of the cul-de-sac there in the Upper Thacker Mountain Road, that's the altitude valve chamber control valve station, we're calling it. And then at the bottom where those 2 purple mains come together, that's where we want to put, we want to make sure that there's a closed valve there to force all of the water up the hill through the forest there and into the reservoir, and then distribute down the roadways from there. This is a top left, there's a dashed blue line. That's simply a loop that can be created to interconnect, to better interconnect those 2 systems. This shows the location of the Riverview well. The bottom left is sort of where that exists. The test well exists today, but as mentioned, it is not recommended to pursue finishing that well. New hydrant needed throughout the system. There's, like I said, there's 3 hydrants that strategically need to be placed throughout the distribution system. Here's another dashed blue line that shows a loop that needs to be created between essentially the 753 system and the 138 system to add redundancy looping. And this shows, it's hard to see, but there's very small, like 1 meter, 6 meters of length needed to simply extend the district system to the 753 system. There's 2 or 3 spots like that. Very simple to do, and once complete will add a lot of additional redundancy. Additional hydrants and sampling ports at the dead ends. Okay, so we'll get to costs. In terms of addressing the question of a second source, of the booster station near well 3, serve as a backup to well 10, would cost in the order of $850,000. Of course, it would provide benefit to both the 753 system as well as the 138 zone, and based on simply water usage, it's essentially 1/3, 2/3, basically right on the money. So in terms of the cost allocation, it would be as presented. Well closures required at 2 locations for this. In terms of looking at the 753 system, the district has 2 of its own wells as well that need to be closed. 753 reservoir improvements, the miscellaneous improvements that I mentioned, which include the liners, the fencing, the ladders, the hatches, the locks. There's a few other little piping changes, grading issues. They add up to about $680,000. And then all of those miscellaneous tie-ins, the sampling points, 7 sampling points and 3 hydrants is an additional $240,000, bringing, I should have put the total there, but I believe it's 1.8 million from memory. So I welcome any questions that you may have. with respect to this presentation.
Excuse me, thank you for your presentation. I'm sure there's a lot of questions from council. Who would like to kick it off? Excuse me.
On that last slide there for the improvements on 285 and then for the 753 system in the 138 zone, 565 is a booster station for the 138 zone to provide service to the 753 then?
So how what that bullet is meant to illustrate is that it's one single booster, and that single booster provides benefit not only to the district's 138 zone, but also the 753 system. If you want to understand the allocation of that cost as it relates to those two systems, just by looking at water demands, it's about 1/3 to the 753 and about 2/3 to the 138.
Yeah, thank you.
Councillor Smith.
Well, the well closures, I agree with those because the one there particular just said it'd be up to 2 years before approval, and we haven't got 2 years to wait. They've already waited long enough out there, and I think that's a pretty good idea to close it off and be done with it. I agree with that.
Councillor Erickson.
So, I read this through correctly, there was one well that you're thinking that has been drilled recently out there that we're gonna use, that you wanna put into effect?
No, the one you're referring to, I believe, is the Riverview well, and that's some work that I think the province has been leading with respect to looking for another source, looking at source options for the 753 system. It is an 8-inch well, it is a 200 millimeter diameter well, has limited yield available from it, and it would not meet the needs of the system.
I thought I read it was 30 liters per second, and then up to 45 liters per second coming out of that well?
It's, at this point, it's rated, I believe, closer to 20 liters a second. It's possible that additional yield could be, it's possible that there is some additional yield, but it would need a little bit more investigation, and certainly the size of the well itself is the limiter. In the short term, it may be able to sustain a short duration, higher flow rate, but certainly, from what I understand, not in the long term.
Okay, so then what you're saying is well 10 and well 3 that we have will serve all of Cockrell Lake area and 138.
Well 3 is larger, and so theoretically it has a better chance of sustaining that demand. But as a whole, I think it makes more sense to instead rely upon the 87 zone as a whole, so not only well 3, but also well 1, 2, and 3, to move water up a zone as needed.
Councillor Medlow.
Thank you. In the appendix, it has a bit more of the detailed costing, and in each of the items up there, with the exception of, which one is this? Some of the district upgrades, I guess. That's probably the $240,000 ones. They were all, those numbers there include either 50% or, in the case of the $240,000, 30% engineering and contingency. So engineering is like the design of the actual buildings and the systems, and then contingency is the construction cost contingency. Is that correct?
That's exactly right, yeah. And so by holding, we would typically see more like the 30%, and that's, you know, in terms of the description of the contingency for the $240,000 item. We feel that there are less unknowns associated with those works, and so we're able to reduce that contingency. However, at the reservoir, because of what we've found with respect to the fact that it will not fill, we've kept a higher contingency to deal with the unknown that remains.
Yeah, I just thought it was a large contingency. I mean, the engineering contingency alone adds up to well over $500,000 there. So that brings the estimate cost right up there. I don't know if there's sort of a historical dollar figure as to how far into contingencies sometimes you need to go, but it makes it difficult to budget with that kind of uncertainty level. And it, makes a decision tougher when you don't have more refined numbers. I understand you can't really get that until you get out there and start doing some work, but that's the highest contingency number I've ever seen, but it does include the engineering components.
Yeah, it is twofold, and it's a good point and a good observation. It is related to simply the fact that we just don't know what's going on up there. And we want to make sure that you're covered in the event that something out of the ordinary is happening up there. And at this point, we can only speculate that something out of the ordinary is happening up there, just based on the observations. Would have been obviously my intention to have that resolved and understood fully before presenting this report, so that we can reduce that contingency down or put an item toward the improvement once we assessed what it was, but unfortunately we were not able to figure it out.
I had one other question.
Go ahead. Okay.
I think even when 753 system was up and running, the properties that are at the top of Thacker Mountain Road, really close to the reservoir, always had poor water pressure there. Is there anything that can be done to increase the pressures in those homes and as far as fire protection as well?
Yeah, good question. The fire protection at the top of Thacker Mountain Road is certainly limited, there's no doubt. And truly the only way to increase the fire suppression potential at the top of the road is to actually move the reservoir to a higher elevation. So that's a very expensive option.
Well, I guess pressure is direct relationship to how close they are to the reservoir.
That's right,
It's
yeah.
meters away.
That's right, yeah.
And if you put it in as a separate zone.
No boosters or anything that can help in that situation?
There are opportunities for boosters. They would have to be looked at carefully to make sure that they wouldn't induce any type of negative pressure situations within the distribution system. Lots of times there's reasons why they would not be recommended. Could be looked at specifically for this if it was a concern, but you're right, the pressures are, I think they're in the order of 30 PSI kind of thing, order of magnitude, yeah. So they're definitely on the low end of the range.
Okay. Councilor Harrison.
Yeah, again, thank you for coming. I'm just wondering about the pricing of how you price this out, because to me, miscellaneous hydrants, I got quite a few underlined here, but miscellaneous hydrants, you're talking $15,000 for each hydrant. That's $45,000 for 3 hydrants.
Plus 30%.
Yeah, plus 30% on top. I mean, that's a lot. So where do you come up with those numbers?
Yeah, good question. So at this level, number one, in terms of the order of magnitude of nature of the cost estimate, it's certainly not Class A, but in this case, I do believe that's the right number, and the reason why is because it would take isolation of the water system, physically isolate, cut into the pipe, add a T, couple the T in place, add a thrust block, add a gate valve for control of the reservoir, excavate in the, enough of the lead, the hydrant lead, to get to the location where the hydrant would be placed. And by the time you look at that as a standalone project, it's in the order of $15,000.
But normally, if you're gonna do this, you're gonna get one guy to put all 3 hydrants in.
But because they're,
Normally, that's what would
given that they're all over the place and you can't isolate one stretch of main and then put 3 in, bang, 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 there'd certainly be some economies of scale at that point. But isolating this section, then isolating that section, then isolating this section, going through those processes 3 times, there's not a lot of opportunity for economies of scale there.
Okay, a quick question for myself here as well. I was reading your notes here about the winter flows have increased in 753, and this may be indicative of a leak in the system.
Yeah.
Can you comment a bit further on that for me?
Sure, yeah, it looks like, when you look at it, I think going from memory, I think it was about around 120 to 140 cubic meters per day seems to be an increase in the winter flows. When you back that out, it's about, I believe, 1.5 liters per second kind of thing, which is not a lot of water as a continuous flow. So it seems to be like it has all the signs of being a small leak. And because there's a water meter at the point of connection between the two systems, that's how you're able to kind of measure that and watch it. So somewhere in the system, we believe we believe that something has happened. It is, in the grand scheme of things, a small flow rate, but we do believe that there has been a small leak developed somewhere. I don't think, in terms of, just to add to that, in terms of water distribution systems, there is a fairly large, generally there's a fairly large percentage of water that's unallocated, whether it be leaks or irrigation for parks and things like that. In this case, it is a reasonably small percentage that it's increased by, but it's increased nonetheless, and just noteworthy that there's something going on there. I think somebody who can acoustically listen for leaks could try and pinpoint what was going on there, but I think it's worth doing.
Okay, worth looking at. Councillor Smith?
The reservoir, is it exactly the spec as the drawings you got, or is it an altered bit, or?
We noticed that the size of the reservoir is different from the drawings, if that,
Someone, they approved it, but it wasn't the same as the drawings,
yeah,
which is kind of interesting.
it is interesting. Yeah, it's almost like they were issued for, I don't know, review or issued for tender or something, but something different was built for some
And
reason.
there might have been discussion too about it.
Exactly,
Everybody was on board with it at the end.
yeah,
Okay. I just thought it was odd that the drawings weren't changed or anything.
yeah.
Councillor Medlock, then Councillor Erickson.
I just want to bring this up now because it is in this report, but it's probably a question more directed to our CAO or Director of Operations, but talking about land ownership and that the land that the 753 reservoir is owned by 753 Developments or Waterworks, one of the two. In our discussions or trying to figure anything out, has there been talk about, because none of these numbers include land acquisition, so has there been any discussion surrounding that as to what would that look like for the district if we were when we take over the system?
Two things, and I'll ask Mr. Dickin to comment on one of them. As far as the agreement goes, any assets that 753 have, including land, cash, etc., will transfer to the district if we come to an agreement. That's the intent. As far as assembling the land for the purpose of bringing the system in, I have not considered it in detail because I just received this report like you, so I don't know the scope, and we'll have to look at exactly where and the size, and then we'll see if it is possible, where it is, if it's freehold, if it's crown, and then we'll move from there. So that may in fact, depending on your direction in future, that may be something that has to be phased because we can't assemble the land soon enough. But that needn't necessarily stop the entire project potentially. Dave, would you say that's probably right?
Yeah, I would agree.
Okay.
Other than that, I believe the only land that would need to be acquired is where the test well is, if we decided to exercise that option, although not recommended. Certainly if the reservoir was going to be moved to a higher elevation, again, not identified in this report, but there would need to be land acquired there. And from my understanding, that Thacker Mountain is, a portion of that is owned by UBC as a trust parcel. So.
Well, I can, just to touch on what you just said there, Kevin, was if we were acquired or wanted to do something with that well on Riverview, the test well, I mean, there's a cost, half of that 30,000 there would be for closure of that well. Since what John just said about having to take over or taking over all of their assets would include their assets, if that is currently an asset of theirs, but it's something that we're not going to use, is it something that we need to do, or is it something that we can at least save on that, or is it a necessary part of the system?
Well, being that 753 Waterworks installed that test well, if we were to take over the system, it would become our responsibility to properly decommission it.
Okay. Councillor Erickson.
So that was half my question. Can you explain a little bit why we have to decommission these wells? Are they not being used right now, any of them?
No, they're not.
What's the wells being used for 753 right now? Aren't they pumping out some well?
Well 10,
well 10.
yeah, District of Hope, well
So
10.
when we took over and none of their wells have been used since then. So why do we shut the wells down? They're just not producing enough water, or they're rusty, or what?
My understanding with respect to Skylark is that was the original 753 well. It simply yield declined to the point where it was unable to sustain any pumping rate that would meet the demands at all. So that's when I believe the emergency connection was made to the District of Hope in 2015.
Don't they have 3 wells out there, or they only have 2 wells?
I believe they only have two wells, the original Skylark well, as well as the newest one that is being advanced by the province.
So, and what does it cost to close each well?
We're allowing.
And what do you do to close each well?
Yeah, good question, and I would like to maybe defer to a hydrogeologist exactly how they do it, but I believe it's a sort of a bentonite type slurry that's pumped into the well to ensure that there's a seal created right up to the surface, so that no water can make its way down the well or around the annulus and into the aquifer, underlying aquifer. That's not our expertise, but in general, that's sort of what it represents. The Skylark well also has some superficial infrastructure on the ground that would have to be removed, so that's included also within that $30,000 estimate, is some of that effort as well.
And how deep are those wells?
Sorry, I don't remember off the top of my head.
They're not 800 feet.
They're not 800
No,
feet.
they're quite shallow wells compared to 800 feet.
They're certainly not 800 feet, yeah.
I'm just trying to figure out the cost of closing.
I've allowed for $6,000 for each of the 2 well closures, as well as and then on top of that, the superficial infrastructure to be removed.
All right, council, any other questions before we move on? All right, thank you for your presentation. We will, our next meeting is Monday, December the 2nd at 6:30 here in the council chambers to make our decisions to make the next steps to move forward with the takeover of 753. At this point, I'll entertain any questions from the public for items relevant to the agenda in the next few minutes before we move into our regular meeting. Or you can hold your questions to next Monday when you'll have a lot more time to participate if you wish. Or if anyone has a question now, we'll try to answer it for you at this time. Mr. Miller.
How much money is in the 753 kitty or whatever? I know there's various accounts, but
I don't have that figure, Mr. Mayor, because it's changing as we speak, depending on the work that Corix is doing for the water controller. As far as investigation continues, works with valves, etc., like that, and accounts receivable and accounts payable. What I will do is I'll present a snapshot of those for the next meeting of the committee of the whole. Those may be useful, they may not. I suspect that, quite frankly, when you look at the numbers that we're talking about here, the actual reserves, well, it certainly won't cover it, but they'll need some augmentation.
And they are still pursuing their accounts receivables.
Yes, they are.
Do you have a number for that, or could you have a number for next week?
I will have a snapshot of all those numbers for you for the next meeting.
Next meeting, okay, thank you. Anyone else at this time? Motion to close. Moved, second, all in favor, opposed, carried. You're welcome to